That's probably it.
I hope so.
Yeah. Hey, good morning. Good morning.
Sorry, they moved the buttons on
They
us.
moved the buttons. Sorry, but that's really kind of my problem.
Yeah, well,
Is this
it's our
still on?
problem.
Wait,
I don't know. It's all good.
Whatever.
Welcome.
Welcome to Azure Flash News,
Yep, and
episode 81.
Episode 81. Today is the 10th of January, 2020. And I would like to say congratulations to us for being in the top 10 Azure podcasts as rated.
Oh, yeah, that's right.
We were number 3 on the list, and it was quite an honor given Azure Friday was number 1. So I'd say we're doing pretty good.
Yeah.
Yeah, very exciting news. So,
Yeah.
so I pat myself on the back here. It's been a while, and we do have some good things today. And I also want to do a little interesting demo because those of you who are doing Azure IoT stuff, or you're just a tinkerer, or you're an enthusiast, you might be playing with some Raspberry Pi, technologies and Python and some other things. And I've been on a little bit of a side project with with one of the MTC architects here at Microsoft, and just kind of want to share some of the learnings that I have, as well as kind of keep you up to date as to where we're going with that project. It's actually kind of fun. I'm not going to give away the farm and tell you exactly what we're working on, but you'll see it when it fully comes to fruition. So
cool. I can't
we've
wait.
got some fun stuff around proximity PPGs. We'll just leave it at that.
Yeah. Right.
Mark Rusinovich did a blog post on some of the technologies and where we're going around how we can make changes without impacting customers.
We're always making improvements here. It's kind of exciting to see this innovation.
Absolutely.
Yeah.
Some perspectives for some of our capabilities that may or may not affect you, but certainly some good perspectives from people that are leveraging the technology.
Well, I mean, we'll get to it.
Yeah, absolutely.
Azure Lighthouse. We'll talk about it in a minute.
And then, of course, some enhancements that we have with some of our performance and our capabilities around disks. And then I'll go into my demo.
Yeah, awesome. Okay, cool.
Absolutely.
So a proximity placement group.
All right.
So do you want to?
PPG.
PPG.
So
is that a paint company?
It could be.
Well,
no, you're thinking of, I know what you're talking about. The Home Depot.
Yeah,
I know.
Anyway, so now we have PPGs.
Yeah.
It's a proximity placement group.
That is correct. So ultimately, when we talk about proximity placement groups, what we're doing is we're talking about taking a set of resources that you have deployed for a workload, right? Mm-hmm. And while we have availability zones, virtual machines,
or
skill sets,
mm-hmm.
what's important is making sure that there's low latency, right?
Mm-hmm.
You may have a high performance workload, or you want to just kind of keep them close to each other, right? Because physically, right? Yeah. Because when we do deployments, we have the concept which we've talked about on the show: upgrade domains, fault domains, mm-hmm. zones. We have a lot of different technologies to ensure that you have availability in the event of some kind of a top of rack failure, or even a data center failure with zones, et cetera. Yep. Well, when that happens, what you might be doing is you might be creating more distance physically, mm-hmm. And creating more latency between resources, because it might be in a different zone, or it might be in a different update domain or fault domain, et cetera, et cetera. Yep. So with proximity placement groups, what we're doing is we're giving you the ability to take resources that have a dependency on each other from a performance or whatever it is, connectivity, and we're giving you the ability to put them in a placement group, mm-hmm. right? So basically, when they get deployed within close proximity to each other. I mean, as the name implies, right?
Yep. Yeah, and so you can move resources in and out of wow, I'm not doing very well.
PPGs.
PPGs, proximity placement groups. You can move them in and out. But of course, as you can imagine, if your virtual machine is running farther away,
yep.
and you want it closer, that would require a reboot. You'll obviously have to come out of your instance, but
yep.
but you'll be able to put things in and out. I'm trying to remember, Rick, back in the old days, we had something that was similar to this. What was it called?
The availability sets?
No, not available. Anyway, I'll think of it later. But
okay.
We've had kind of a concept of this where it's like where we've had sort of this physical closeness, and it kind of got left behind a little bit. I think
spanning and pinning.
No, it was like the old Azure V1 stuff.
Oh, okay.
And so I think we're finally getting back now to being able to provide metadata around virtual machines that need to be physically close to each other in the data center. And so we can do that now.
Yeah. No, it's
and what I was going to say about that is, in that technology, you had to create the machine in that group to start with.
Oh, correct.
But with proximity placement groups, it looks like you can add them.
You can add them. Yes, correct. And yeah, so this is really important. Again, if you're deploying workloads that have got, well, I would just argue best practice wise, right? If you've got workloads that you're deploying, it's probably best to keep them in a proximity placement group. That way you can ensure connectivity, low latency, availability, consistent with, the other machines that may or may not be available depending on what's going on. So arguably, if you have the ability to take an infrastructure as a service workload and provision that into a proximity placement group, I would recommend it.
Yeah, yeah, and you would want to think about doing this per application, I think. I guess you could kind of like put a proximity placement group around every single VM you create.
Yep.
But I think the intention here is a little bit more application focused.
It's definitely workload centric.
Right,
Absolutely.
workload.
Yep,
Yeah, that's
totally
a good way to put it. So in other words, if you have an application that has 3 of these VMs and 2 of those and a scale set for this, for that app or that workload, those are the things that need to be in a proximity placement group.
And actually, what I would encourage you, if you're a listener, or if you're tuning in on YouTube, whatever it is, the associated blog post is interesting because it has best practices that we've developed ourselves.
Yep.
So for use proximity placement groups in conjunction with single root IO virtualization or SRIOV to a VM to get even more network performance.
Yep.
Deploy them in a single template when you've got resources. Deploy them in the same ARM template, basically. It increases the probability of having all your VMs successfully deployed, right? Because if there's capacity constraints or if there's something that happens, because remember, when a template fails, the whole template fails.
Yeah.
Right, and that's kind of what you want with a proximity placement group is if something goes sideways, whether it's our fault or your fault, you want that to kind of fail as a unit, right?
Yeah.
There's some other things in here, but I'll absolutely, I highly recommend going out and taking a look at this. While a PPG can't span zones, the combination of availability zones and proximity placement groups, now I'm doing it, that combination is really powerful too, right?
Yeah,
so,
for sure.
So if you've got a proximity placement group here, and then you've got zone availability for some of the other resources that can't be in part of IaaS, like storage or something else.
Azure storage.
Exactly. Sorry, Azure storage, I should have qualified that. Very, very powerful from an availability and low latency perspective.
Yeah. So the capabilities around both providing availability and resiliency, and now what ility is speed? I don't even know. Performance ability.
It's performance. Security and performance don't end in ility, but they still fall in architectural illities.
Yeah. So this one is more of an architectural speed ility.
And so last, but one thing I just want to call out quick too is one of the last when they talk about best practices is use proximity placement groups with Azure VM scale set new features, which are now in preview, which now supports heterogeneous VM sizes and families in a single scale set. Heterogeneous in a scale set.
Wow, I didn't know you could do that.
I didn't either. So this is awesome, right?
You learn something new every day.
Yeah, so you get high availability, you get fault domains in a single availability zone, but you can use custom images and different SKUs and sizes, so you can really create an interesting combination of resources for that.
There's so much you can do in infrastructure as a service. So, so anybody who says that lifting your on-prem VMs into Azure is just sort of, I just
lift and shift.
It's lift and shift. It's the same thing. It's really not, because you have all these capabilities with. Just think about it for a second. If you lift your VMs into Azure, what you've done is you've gotten rid of all of your storage components. You've moved into Azure disks. You now have a single monitoring plane. So anyway,
your control plane is unified. Your back plane is unified.
You have Azure policies.
Yeah, there's no such thing as lift and shift unless you're literally taking a single instance VM, putting it. You know what I mean? And even that.
Even that's not.
No, I know it's crazy.
Anyway, so
that's why we say move and improve.
That's right. Move and improve. That's Rick. I let Rick.
That's not me. That's not me. That's that's
I was always attributing it to you.
No, I wish.
Okay. All right. Cool. Let's do some low impact maintenance.
So Mark Rusinovich.
So
the man, the myth, the legend.
He is.
Right?
Wow. He's kind of like well, it reminds me of C-3PO in Return of the Jedi when all the Ewoks are like,
go
worshiping God,
go.
Right. So he's kind of,
Or if you watch Family Guy, when they do the spoof on it, it's gold guy, gold guy.
Anyway, so he's very well revered, well respected.
Oh yeah, well respected. Absolutely.
He's been doing a lot in this space. I mean, I remember going to our internal conference.
Yes.
For a long time ago when he was actually talking about all this stuff, and it was just an idea.
I remember a couple of years ago. There will come a day when you will not have to reboot a machine. That you'll never have to reboot a machine in Azure again. I remember him saying
due to our maintenance, at least.
Yeah, and I remember thinking, baloney.
and we're about to go through 4 technologies that we have in Azure to help make that happen.
Exactly. There's some really cool stuff. So, of course, I would almost call this somewhat military, right? Because people in the military don't do anything without a plan, and they have a backup plan, and they have a backup plan to the backup plan, and they have, right? So in some respects, it's somewhat military in how they approach this, right? So we've got plans A through
D.
D.
And what this really is about, remember, this is very much infrastructure as a service. So we're kind of continuing with the infrastructure as a service theme here. You are responsible for the OS on your machine and up. So in other words, if you have a patch on the OS on your machine, that's your responsibility, not ours.
Correct.
These are technologies that reduce the forced reboots from us updating our hardware and virtualization layer. Because you remember in IaaS, Microsoft is responsible for the hardware, the physical network, and the hypervisor layer. If there are updates to those layers, how do we reduce the amount of downtime that you, the customer, have to take due to our updates? And now we can go through them.
So, okay, so this is interesting, right? So plan A, to your point, hot patching, right? So function level hot patching is basically making changes to actual running code without incurring downtime. Okay. So what's interesting is according to this, it redirects all new invocations of that function on the host to an updated version of the function. So it's almost like you've got them running side by side, but it's almost like having a load balancer, right? You're stopping any new traffic going here and going here. So arguably, it's probably similar to how we're directing back when we developed the drawbridge technology and we started load balancing at the hypervisor level, some of those things. In theory, it's kind of similar. But what's really kind of cool about this is we've been working with hardware manufacturers to consider our own firmware to make them hot patchable and incrementally updatable. So we're actually working directly with the hardware manufacturers to make this, hot patch, fix in place firmaware. So
as much as we possibly can.
And to me, when firmware, that's crazy. You know what I mean?
And then you can see here, this has been a little bit of a journey. It says we have been using hot patching in Azure since 2017. Right. So it's not new.
No.
Not recently.
No.
And as an example, we updated to allow the hypervisor to be hot patched in 2018. So this is a constant, ongoing capability for us. Was how can we start to swap out pieces of the hypervisor and the OS on the hardware, not your OS, not in your VM.
The host OS.
The host OS. How can we start to hot swap as much as we can? So that's the first thing we try.
That's the first thing we try. Now, some large host updates might contain changes that literally, I mean, they can't be applied using app level hot patching. So for those, we use memory preserving maintenance. Right.
This is cool. This I don't know if they ever. So basically, what we do here is,
and we've kind of talked about this. In the past,
This is not. I mean, this has not been. Well, I remember when we first heard about it. It definitely was
well,
top secret.
Yes, it was when we first heard about it.
But now it's pretty well known that we do this. And what we do basically is we take the memory state of your VM and we hold it in state. Pause. And so you'll see your VMs pause for a second. And we do whatever we need to do under the covers to quote, if you will, reboot a driver or a subsystem on
Typically,
the host.
it's a service, right?
Service. If we have to basically, in some ways, what would normally have been a reboot, what we can do is we take and suspend your VM in memory, swap out what we need to, and then let your VM start.
And then go back and literally pick up right where it left off.
And so your VM actually never misses a beat.
No.
Except that it does pause for a second.
It does pause.
But there's no reboot.
You don't lose state, you don't lose memory, you don't lose anything. It's not like we flush any caches or anything like that. Basically, we pause it, and you continue on. And what's interesting is we've been doing this since 2018. I know, and so
by the way,
and so it's not new, but it's not old. You know what I mean? It's I mean we're just in the beginning stages of 2020 here. So now and there are rare cases, right, where we truly have to make more impactful maintenance, including a host reboot. Right, that's like every critical service is getting patched or updated, so the host literally has to be bounced. Right, we do notify.
We really hope this doesn't happen.
Exactly.
I think in some ways, if you think about a complete reinstall of the host OS,
exactly,
something of that nature,
something
where it's really
major,
very bad.
Yep. So in that case, though, we do give the customer the opportunity for self-service maintenance, right?
Yep.
So you can pick your window, you can decide, or you can proactively say move it now and move it to a machine that's already been patched. So we do offer a lot of different opportunities for you to actually let the fix happen, but on your schedule, not on our schedule.
Yep.
And that's really important.
So in other words, we're going to have a fleet of already patched, already rebooted hosts. It's your choice to go into a time window and say, move me now.
Yep.
And when you do that, it'll reboot you right then, move your VM to an already patched host and bring you back up.
Yep.
So then at least, hopefully we don't ever have to make you move, reboot. But if we do, we're going to give you some control over when you want to do it.
Absolutely. So we actually started this. So in addition to that, we recently started, if a customer's using dedicated hosts or isolated VMs, which is more higher tier, higher performant, you've got these very specific requirements. We started to offer maintenance control over all, so non-zero impact platform updates. So there are certain things that we just can't avoid, right?
Yep.
But if it's a zero impact platform update, it's a rebootless update that basically you're still going to get that pause. But again, if you're running dedicated hosts, I mean, this is the same situation where you're now going to see the same experience, but at the higher tier of capabilities. It's not just the farmed out commodity field of servers running. It's even on your own dedicated host, we're doing the same thing.
Another thing that it kind of points out here, this is another good point, is that hardware degradation can be another reason.
That's a great point.
If the hardware, if we're noticing that the processor is starting to overheat, and when we, for whatever reason, determine that that means it's about to go out, we would rather preemptively say, hey, let's get off this host, schedule some maintenance, move you off on your schedule, rather than having an unscheduled outage where the host goes down, and then now you have an unscheduled outage. Although we'll probably move your host and spin you back up, but still it's unplanned.
So, and that's exactly what brings us into Plan D, right? So in the event that you do have a hardware degradation, the best option is really to initiate a move of the VM to another host, right? Either customer control or plan maintenance or through live migration. So Plan D, if plans A, B, and C aren't viable solutions, Plan D is, of course, live migration, where we will move a running customer VM from one source host to another destination host, right? Live migration, basically, we take the local state, including RAM and local storage, so scratch disk, memory, all that stuff, and we basically go from location A to location B. And there's a short pause, about 5 seconds or less, and after the pause, the VM resumes running on the new host.
That's
so
awesome.
Again, here's a situation where we're not bouncing you, we're not flushing things from memory, we're not forcing you to go rehydrate singletons, we're not forcing you to go restart things and take the just-in-time compilation overhead of rebooting that machine, not to mention the fact that you may have lost a bunch of stuff. We're not doing that. That's not happening. You are literally pausing for roughly 5 seconds, give or take, and then you're continuing on as we migrate you to a new host.
And I was going to say, I think people are pretty familiar with live migration through VMware.
Absolutely.
And so this is the same technology to do that. I also wanted to point out that, we've been actually doing this live migration for preemptively moving people off of degrading hardware since 2018.
Again, 2018 was a big year.
so this has been going on a while, and you'll notice we didn't really say much about it in 2018 because we just want for you to experience.
We shouldn't. Yeah, we should. You should just be like, oh.
You really shouldn't care.
Exactly.
You should just be like, it should be up as much as possible.
Exactly. We'd prefer you not have to worry about that.
Now, I will also point out that there is a recording of Ingal Figlin's Ignite 2019 video, where they go into more detail on this. So you want to know more about how we predict hardware failures? Check this out.
And I'll tell you what, it is interesting. And I'm not saying go read this if you want to fall asleep at night. Like sometimes I qualify white papers and stuff. This is actually interesting stuff. And if you truly want to understand how Azure operates, like if you truly understand what differentiates the cloud, because a lot of people say, oh, the cloud is just you're hosting it on somebody else's equipment. No, it's not. No. And I tell you what, you are not doing this on-prem. I guarantee it. So,
and customers on between 2017 and 2018 to start using this, what do they have to do?
Bupkis.
Nothing. Nothing. Okay, so go check that out. We're going to continue to work on this stuff. It's awesome. All right. Azure Lighthouse.
So this one I thought was interesting. So Azure Lighthouse, but from a managed service provider perspective. Okay, so Azure Lighthouse is a really cool technology, right? It basically came to fruition in July of this year, right? So we are seeing a lot of service providers, managed service providers, right? Which is basically they're managing basically customer technology, right?
Yeah, you might say
like a rack space or
yes.
like that type of situation where you've got a solution, but they manage it, they monitor it, they take care of care and feeding for you. And what we've done is we've given them this technology, basically, which allows a partner to manage multiple tenants across one single control plane.
Yep.
So Lighthouse gives you the ability to see, let's say you have 1,000 servers across, let's say 20 customers. You can see all 1,000 servers without having to go into every single one, log in, have special credentials, do all that stuff. You basically have a single pane of glass across, and so you know health, you know state, you know all the stuff you need to know, right? So it's really kind of interesting. So basically, you can do daily administration tasks across all your customers from a single control plane, right? Securing intellectual property. There's a few scenarios, that they talk about specifically in this article, but like monitoring alerts, Azure automation. It's a unified place. Now, the one thing I thought about though is I've dealt with a couple different customers where they may have more than one tenant. And so in theory, you don't have to be a managed service provider to leverage this technology across multiple tenants.
Yeah.
So you as a customer, for example, you may have a management tenant that you use specifically for certain things. You may have, I'll call it an operational tenant, or you're creating trust boundaries between different groups. That doesn't mean you can't still manage and monitor it, right? You can still do that. And that's what I think is really important. You've got the Graph Explorer, you've got Azure Alerts, you've got Azure Automation, and you can actually leverage these across all those tenants.
Yeah.
So if you wanted to programmatically go in and say, oh, every single one of my tenants, for some reason, this particular VM that gets deployed doesn't have disk encryption. Yeah. Done.
Yeah. And I think what I have found so interesting about Azure Lighthouse is that it's like the meeting place of the managed service provider and your tenant. In other words,
it's kind of like online dating.
Yeah, a little bit, a little speed dating. So the VMs or whatever it is still in the customer's tenant.
Yes.
So all of the infrastructure
and
is
that's
in the customer's
important. That's
tenant.
an important
so
distinction.
This is important to say. But the managed service provider essentially gets a place in the Azure portal where the management of that infrastructure is projected for them. So in other words, you could imagine, like in the old days, you had to give the managed service provider direct access to your data center, logins, whatever.
Yep.
But that's not what we're talking about here. We're saying you project the management of your infrastructure into the service provider's
tenant.
Portal.
It's hard. I know it's
kind
like,
of hard to call it.
It's I just refer to it as tenant, and I know sometimes that term's a little bit overloaded because you've got an AD tenant, you've got but it's probably the best way to describe it is multi-tenant type of you're projected into that tenant specifically for those resources that you manage.
And so like especially for this Azure automation thing here, so if you're a managed service provider and you have some nifty Azure automation scripts that automates all of the management of so if I'm the service provider, my customers, I'm managing their VMs, and I do a really great job of building this library of Azure automation. I don't want that to be in my customer's tenant.
No,
because that's my IP. Yeah, I want it in my tenant. So now I can go into my managed service provider tenant, build some really awesome scripts, run them against all of my customers, which are in other tenants.
Right.
So it's this meeting place of the managed service provider and the customer, and being able to work together and have a really nice boundary. So you have to remember, so for those of you who are out there who work at a managed service provider, you guys should look at this. But if you work at a customer and you might use something like this, now you can be thinking, this is an interesting way for me to outsource or get a managed service provider. So it's still interesting to both parties, even if you're not a managed service provider. Think about it as now you kind of understand what capabilities you might actually go to. I guarantee you Rackspace does this.
Oh yeah.
Because I know that they're into this business.
Right.
You could call Rackspace and say, hey Rackspace, I want you to manage our stuff and I want you to do it through Lighthouse. So I still have all of my resources here, but you guys get all of the management aspect.
Yeah, absolutely.
Very cool.
So
very,
I think
very
it's cool. I think it's slick. And the user access I think is really the important piece, right? to me, the reason I like this is from a security perspective. You're not creating, a security administrator. You're not creating those. It basically, it allows you to control the RBAC aspect of it.
Yeah,
so
and you just don't
that's
need.
A big deal.
So the managed service provider doesn't need an administrator account in the customer's tenant.
Exactly.
We're keeping those two things separately. Remember, we're gonna project it in. Anyway, it just keeps the boundary really nice. We
love those trust boundaries.
Yeah, I mean, we bring them together, but we don't force them to cross.
Correct.
Very cool.
Yeah, it's like taking a horse to water.
That's right.
Not making them drink.
That's right. You can't do it. But anyway, check it out. There's all kinds of stuff in there.
Absolutely. So before we hop on to that quick demo, we've got a really cool, fun announcement about an enhancement with Azure Disks.
Yes, we do. Now available in the SSD tier of our disks, which is both the P tier and the E tier, which are the standard SSD managed disks.
Yes, they are.
There is now going to be a credit-based burst capability.
That's cool.
And what we mean by that is, if you've used the B series VMs, then you'll already know how this works. For all of the time that you spend sort of at a very minimal amount of usage, you build up credits for bursting. And then you can go over your allotted amount up to the amount of the credits that you built out.
That's cool.
So that and I love this, it says actually bursty.
I know, bursty.
Bursty.
Is that a word, bursty? It's
a
bursty workload?
Yeah, that's what it says here. So I'm going with it.
I like
no, it doesn't say bursty. It says spiky. Spiky. So for spiky workloads, I love that. For spiky workloads, we can actually handle those a lot better because if it's low for a while and then spikes, we'll actually let you go above.
Yeah,
you can exceed,
a lot. Yes, which is cool. So you can exceed your IOPS. So you can max burst IOPS per disk. So your provision IOPS per disk, for example, in this case, in the one example of P1 is 120.
Yep.
But
I'm
you
highlighting
can max
it here
burst
on the video.
IOPS per disk to 3,500. That's huge, right?
That's a lot.
Yeah, or to
that's
go
like
from
order of magnitude more.
Bandwidth of 25
MB-bytes.
Thank you.
Gigabytes. What is it? Oh, it's MB-bytes.
MB-bytes to 170. So 25 to 170. And the duration at peak burst rate for these is 30 minutes. So it's not like you're just, it's just boom and it's done. Boom and it's done. You can sustain this for up to 30 minutes.
As long as you have the credits.
Correct.
As long as you have the credits.
Exactly.
So, I mean, and I'm just trying to think of what you need to do to get to start using this.
Nothing.
Pretty sure nothing.
Well, okay, so not true. So P1, P2, P3, right?
Those are just new SKUs.
Oh, those are new
burst capable
disks.
Yeah, those are just new. We've just never had 4, 8, and 16. So we've just never had those.
That's a great point. So technically, you don't really have to do anything.
I don't think so.
No.
Yeah, I don't think so. So it's pretty cool that this burst capability is just available both on all P1 through P20 as well as E1 through E3. So go check this out, or actually don't.
Or don't.
Just let your VMs use it. Pretty cool, pretty cool.
Yeah.
Okay, so we're going to transition over to a little demo.
Now, I just realized, though, that I need to project. So
we can do that. You are plugged in.
Not yet, but I am.
We're kind of throwing for a loop.
We're doing this on the fly here.
Sorry.
Forgot about this. So I am plugged in now, but somehow yours has got the display.
I know, Emily's going to have to switch us.
Oh, is it?
No, Rick's is,
let's see.
No, it's okay. Rick has his Visual Studio Code open now. Not this machine.
Oh, look at that.
Okay, we're going to do it on the fly here. We're going to do it.
Yep, we're going to do this.
Do you want to come out here and do it real quick?
So basically what we're doing is we've got this set up so that that particular machine that Mark has is what's projecting onto the screen.
Yeah, we're getting the screens projected. We threw it for a loop here
So what I want to talk about today, so within the IoT space, a lot of work happens on the Raspberry Pi, right? It's an easy, convenient form factor to do and it's cheap, right? Low cost, that kind of stuff. So recently, I've been enlisted to help one of the MTC architects on a side project, and it involves a Raspberry Pi with some display capabilities, but being able to control it. So so basically, without giving the farm away, what I'm doing is I'm treating this Raspberry Pi like it's actually the vision subsystem of the brain. Okay.
Okay.
And so what it's doing is I'm telling things where to look and doing pupil dilation and blinking and a bunch of other stuff. As you can imagine, so again, I'm not a Python guy, so I taught myself a little bit of Python. And I was also trying to figure out, well, how can I remotely interact with this Raspberry Pi, right? Because I'm gonna need a different bodily subsystem of the brain component, right, to talk to the frontal cortex or whatever it is that controls the vision subsystem, and make all these things happen. Well, back and forth, back and forth, back and forth. So what I did was I went ahead and I installed Raspbian on a virtual machine. I created a VM in Hyper-V.
Okay. So I've on your local machine.
On my local machine. So I'm running Windows 10, and I've got this. Whoops, wrong one. Sorry, that's Docker. I don't want. Raspbian is the one I want.
There we go.
So I'm going to start that and fire this one up, and you should see this pop up here. There it is. Okay, so this is coming up, and this is basically running a version of Raspbian that's got a GUI to it. So you can use CLI, you can use GUI. I'm a GUI guy. It's just how I roll. I know. I'm pathetic. Okay, I'm old.
Wow, look at that. It has a desktop.
It has a desktop. Yeah, it has a desktop, and it's got networking, which in this case is really important, right? So do this.
You want to talk to it. Networking is important.
Exactly. So 172.23. Wow, this will become okay. So the first thing I did was I created this project, and I'm just going to go ahead and open this. And I'm going to start this project. Eye controls, boom. So you can see we've got a set of eyeballs, okay? Now the question is, how can I remotely interact with these eyes to make them, for example, if Mark walks by, look at Mark? Or if somebody approaches and he's a little bit angry if the pupils dilate, right? So what I did was I went ahead and I set up on this virtual machine, back up here, right here. So I'm just going to exit this for a second. And what I did was I set up this file called iControls. So this iControls.py file, basically what it does is it invokes an HTTP handler. So what I'm doing is ignore the code, it's horrible. There's no error handling, there's no range validation. Well, there's a little bit of range validation, but so basically what it's doing is I've got an HTTP listener that basically starts up and it's running on port 8000, and it's just looking for incoming query string parameters, okay? And basically then it's taking that and it's setting these global variables for the eye, okay? All right. So if I close this and I go back to this again, I'm going to fire up these eyes, okay? So my eyes are running. Now I'm going to go into Visual Studio. I'm going to run this. Now it's really important though that I know this IP address before I should have. Let's see.
Grab your IP.
Yeah. Back here. Okay, so the IP address 172.23.250. Okay, so 173.23 or 172.23.52.54.7. Okay, so.
You want me to write this down?
Yes, please.
Okay, I'll type it in right here. What is it?
173.
173.
Sorry, I got a mouse over. 23. I'm sorry, 172.23.
72.
Yep. Dot 23. Dot 254.
254.
Dot 7. Okay.
So I've got it typed in.
All right. So we're cooking with gas again. So I'm going to go back here again, and I'm going to run this. I'm going to fire this up, and so I've got some eyes blinking and looking around. Okay. So you can see this changes.
172, 23,
23,
254,
254, 7. Okay. Okay. So that's all right. So 7. Sorry, 7. Okay.
Oh, it worked.
So you can see I've got a status. Okay. Now what I want to do is I'm going to go ahead and I want to make the eyes look that way. Boom. Oh. And now I want to make the eyes look up. Boom. And now I actually want to change the pupil dilation.
For those of you not watching on the video, you should.
Okay, so I can control these. So this is a C# application that I wrote that simply passes, it invokes a HTTP web client.
So you didn't write the Python that does this.
I heavily modified the Python. Okay. I had to modify the Python because the Python was designed to interact with GPIO. So it was designed to interact with a board that would be sending signals from, say, like a joystick or push buttons to make the eyes move.
But you didn't do any of the graphics.
No. This was all done
using. Rewire it.
Correct. I rewired everything. Cool. I have done graphic works like this, 3D stuff like this in the past in a past life. So I do know about bar plane and near plane and viewing frustrums and all that stuff. But in this case, it was more about manipulating the actual eyes. So yeah, so basically now the next step then is to take this C# code and essentially create emotional states, right? Or attentive states. So for example, the other thing is I've got two very small LCD displays, one for each eye, and they're going to be placed someplace. And I'm gonna, that's as much as I'm gonna say about that, because
there'll be more.
It's part of the fun. But eventually this will make its way into the MTC factory, and you'll
in
see
Minneapolis.
In Minneapolis. Yeah. And hopefully you'll be able to interact.
Hopefully you'll come and see it.
Yeah, absolutely.
We'll let you know.
But it was super simple. So like I said, I took a Raspberry Pi, but to me the fun part about this, to be completely honest, is doing this, because so you can see here I'm grabbing my query string. So eyes X, eyes Y, and then pupil dilation. So I'm just outputting that so I know what's going on.
Oh, wow.
But it was fun because once I realized I don't have to go SD card to copy, the SD card to change the Pi file, put it in the Raspberry Pi, start it up, it's broke, change it, right? Boom, fire up a virtual machine.
Oh, and you're connecting to it from Visual Studio right into
exactly.
the local host of the Raspbian.
The 170, okay. Yeah, exactly. So the next steps, so there's some other components here that you're going to start to see, and why am I bringing this up? Because this is an Azure conversation. Cognitive services should play a part in this. Object detection, image recognition, age detection.
Yep.
So those are all going to influence, for example, I would like these eyes to get softer and kinder if they see someone who looks like they're maybe 10 years or younger. Or for example, if they detect somebody, I want the eyes to follow that person as it moves across the room. Yeah. So this will be wired up into probably the Azure Connect sensor, as well as cognitive services in the near future.
That's awesome.
Yeah, fun
That's
stuff.
Cool, man.
And I absolutely am happy to put this up in GitHub if anybody's interested in playing with it, if they want to do their own thing. A lot of the hardware that was purchased off the adafruit.com website. Yep. So if you want to have the eye controllers, the Raspberry Pi, whatever it is, it's all available. Anybody can do it. In fact, the base source code that I started from with the Python is in GitHub as well. I just abstracted it so that it was manipulated by code HTTP. Instead of, yeah, exactly.
Okay.
Yeah, so there you have it.
That was cool.
Yeah, it's fun stuff. So if you have any questions, concerns, comments, cheap shots, remarks, or anything else, you can reach me at rick@microsoft.com, or of course, you can always reach us at Azure Flash News on Twitter.
You can catch me at mgarner on Twitter, or you can email me, mgarner@microsoft.com.
Yep.
And a shout out to the Azure user group. I spoke there last night. I should have mentioned the show. I didn't. I'm sorry. Sorry about that. But I didn't want to send a shout out to the Minnesota the Minnesota Azure user group. So they were great. It was about 70 people there. So it was a big group, and it was really cool.
Yeah, very cool.
So then catch us. We'll continue uploading the show to YouTube. We'll get to see Baby Yoda. Very important stuff going on here.
I had to give Baby Yoda a little screen time.
I knew that was going to happen.
I had to.
You can catch us on YouTube, Twitter, Twitter, yeah.
iTunes, YouTube, Twitter, Stitcher, Google Play. We're everywhere, man.
Yeah, and if there's somewhere we're not, let us know.
Yeah, but please let us know if we're missing a format that you would prefer.
Yeah.
Yeah, absolutely. Well, per usual, we thank you so much for taking the time to listen or watch, and just tuning in is great, and we hope you learned something from this. And as usual as well, we look forward to chatting with you same time, same place, probably not the same time, but within the near future. So until then, keep your fingers on the keyboards and your head in the cloud.
Thanks, everybody.